In this video, we're going to finish the remaining problems that we have here. You can take a look at the answers in this video or the filled-in version. If you're very comfortable with this, like I said, you can just fast forward and take a look at the answers or pause and go slow with me as you see fit. So in the first case, we're going to round these numbers to two significant figures. So we can see here, for example, 2 would be 6 point, that 2 area, that 10th place. Look next door, rounding up to 6.3. Here we want to round to the ones place over here. So we look next door, rounding up. And so that's going to leave us with 20. Now, this is one significant figure, so to really make sure we have 2, we have to put that point there, or you could say 2.0 times 10 to the power of 1 in scientific notation, because everything is significant over here. Here, let's see, so we're going to have 2 significant figures. We look next door, we round up to 43. Here, 2 significant figures. Look next door, we round down to 34. 2 significant figures. Look next door, round up to 17. 2 significant figures. Look next door, round up to 4.1. Let's try an exercise where we round to 3 significant figures this time. So we want 3 significant figures right here. Look next door, we round down to 5.38. That's 3 significant figures. Here, we went up to here, so look next door, we round up to 10.3, 3 significant figures. Here, 1, 2, those are all significant there. We look next door, we round up to 32.3, 3 significant figures. Here, we want to go up to here, and we want to look next door, round up to 3.77, 3 significant figures. Here, we want to round up to there, look next door, round down to 2, whoops, let's erase that. 2, no, we don't want to highlight, we want to draw 2.68. And then we want 3 significant figures here. So 1, 2, 3 up to there. Look next door, it's a 5, it's already even, so we're going to round down to 3.08. And that's 3 significant figures. Here we're going to round the numbers to the nearest thousandth and then state the number of significant figures that are there. So thousandth place, so 10th, 100th, 1000th would be right here for this one. And we're going to look next door and round up to 16.447. And that is 1, 2, 3, 4, 5 significant figures. Here to the thousands place, so we have 10, 100, 1000th. Look next door and we round down to 6.567. And we have 4 significant figures. Here we want to round to the nearest thousandth. So this is a 10th, 100th, 1000th place here. Look next door, we're going to round up to 0.067. And we have 1, 2 significant figures because the zeros before them do not count since they're leading zeros. Okay, so 10th place, 100th place, 1000th place. We look next door, we're going to round up. So we're going to get 0. That's going to become 10, so it gives 1 more to that 8 there to become 0.790. And so now we have 3 significant figures over here because the 0 counts since we have a decimal place in front of it there. Now, let's go to this one. 10th, 100th, 1000th place. Look next door. That's not even yet, so we're going to round that up to 4.770. We're still at the 1000th place over here. And so we have 4 significant figures right there. Okay, now we're going to go to this one here, the 1000th place. So we have 10, 100, 1000th. Look next door, it's already even, so we're going to leave it to 1.234. And we have 4 significant figures there. And then lastly, we're going to go and take a, well, not lastly, there's 2 more parts actually. So we're going to round to the indicated numbers as indicated there. So this to 2 decimal places, we'd have 4.2. To 3 decimal places, we'd have 48.693 because we're rounding up there. To 1 decimal place, so we'd have 0.8 because we have to round up to keep it even, to get it even. To the nearest 100, 100 would be, this is a 1, and this is the tens, this is the hundreds. So you look next door and it looks like we're rounding down to 600. And we only have 1 sig fig there. And if you want to keep the same number of sig figs, you'd have to put your scientific notation. You'd have to indicate that with a decimal point. It really depends on the question. So 2.076 to 2 decimal places. So let's see. If we're rounding down to 2 decimal places, we're going to be over here. So that's going to be 2.08, and we have 3 sig figs there. If we're rounding to the nearest 10, so this is 1, and this is 10s there. So we're rounding down, so really this is going to be 10 over here. And if we're rounding to 2 decimal places here, so we have 0.698. We're going to round up in that case, so it's going to become 0.70. We have 2 sig figs there. 95.89 to the nearest 10. So this is 1 and this is 10 over here. And looks like we're going to round up, and this can become 100 to the nearest 10 there. And that's with 1 significant figure. Over here, to 1 decimal place, we look next door, we want to round up to get an even number, so 23.4. And that's 3 sig figs. And then the nearest 100, so this is 10, or 1, 10, and 100 right there. Look next door, looks like we're going to round up. And so we're going to get 5,800. And we have 2 significant figures. If you wanted to maintain the same number of significant figures, you would then have to add decimal points or do scientific notation. So for example, here I had 1, 2, 3, 4, 5, 6, 6 significant figures. So I'd have to do 5800.00, and this would be 6 significant figures. Here I had 4 significant figures. So if I want to make that 4 significant figures here, I'd have to do 100.0. Here I had 1, 2, 3, 4, 5 significant figures. So to make that 5 significant figures, I have to do 10.000, and now I have 5 significant figures if I want to keep them to the same value. Same idea here. I have 6 significant figures, so I'd have to do 600.000 to maintain the same number of significant figures. But it really depends on what your question is, right? If your question has fewer significant figures, then you're going to have fewer than that. So you have to look at that question very carefully and what the operation is that you're doing. And now lastly, let's do these ones here. We're once again asked to round. In this case, I'm being asked to round to 1 significant figure. So somewhere around here. I look next door. I'm going to round to 3. Here I'm being asked to round to 2 significant figures. So I want these 2 here. And I need to, it looks like I'm going to have to round up to get it even. So I'm going to have 7. If I leave 7, that's only 1. So 0.0, that's 2 significant figures. Here I'm being asked to round to 2. So if I look next door, I'm rounding down to 33. Here I'm being asked to round to 3 significant figures. So if I look next door here, I'm rounding up. And so that's going to become 7.6. If you leave that as 2, make sure you put a 0 there to have 3 significant figures. Here, 2 decimal places. Be careful, 2 decimal places. Right there, I'm rounding up. So I get 26.50. There's 2 decimal places, but 4 significant figures. Here, I want to keep 4 significant figures. So 1, 2, 3, 4. Looks like I'm rounding up. So 77.30, and there's 4 significant figures for you. 3 decimal places. So 3 decimal places will be up to here, and looks like I'm rounding up. So 8.210. There's 3 decimal places. 3 significant figures. So 1, 2, 3, and it looks like next door I'm going to be rounding up. So 5.61. There's 3 significant figures. 3 decimal places up to here, and it looks like I'm rounding up. So 5.610, and that is 3 decimal places, but 4 significant figures. 3 significant figures here, so 3, 3, and 6. Looks like I'm rounding down, so 33.6. And that would be 3 significant figures, or 1 decimal place. And so that is this worksheet on rounding based on parameters given to you, not so much based on questions with scenarios.